The paw print in the snow measured 15.8 centimeters across the pad. Field biologist Kenji Osawa knelt beside it in the pre-dawn cold of Shiratoko Peninsula, notebook open, breath fogging over a track that shouldn't have existed by any published reference range. It was March, 6 months into a fenced rewilding trial that almost no one outside Hokkaido's forestry ministry had been told about, and the motion sensor camera bolted to a hemlock 40 meters away had caught something at 3:14 a.m. Not clearly, not usefully, just an afterimage. A blur of orange and black moving faster than the shutter could resolve. There and then, not there. The kind of frame conservation biologists learn to file under inconclusive and file away. What made the morning different was the radio collar. Tiger 7, a 3-year-old male Amur tiger, one of 6 animals released into the reserve's interior the previous September, had gone silent 11 days earlier. GPS pings from these collars are supposed to be reliable to within a few meters, transmitted every 4 hours, uninterrupted. And then, without warning or explanation, they stop. The research team assumed equipment failure. Batteries fail. Antennas snap on brush. It happens. Then, on the 12th day, the collar came back online. The coordinates did not make sense. Tiger 7 was 40 kilometers outside the reserve's perimeter, a perimeter built, at considerable expense, to be tiger-proof. Double-fenced, electrified, monitored by infrared. Nothing about the containment design accounted for an animal covering that distance undetected, through terrain that included 2 prefectural roads and a fishing village, without a single confirmed sighting by a human being. There was no kill site, no livestock report, no trail camera hit along the most direct route between the reserve and the tiger's new coordinates. Just a paw print, too large for the reference charts, a collar that had gone dark and come back with an impossible story, and a piece of northern Japan that, as far as the international scientific community was concerned, had not hosted a wild tiger in 12,000 years. The official record is unambiguous, and it has been unambiguous for a long time. Panthera tigris does not appear on any modern species inventory for the Japanese archipelago. It is absent from IUCN range maps, absent from Japan's Ministry of the Environment Red List assessments, not as an endangered resident, but as a category that does not apply. A species with zero historical overlap with the islands in any time frame considered biologically relevant. Textbooks describing the fauna of the Japanese Pleistocene mention the tiger only in the past tense, and even then, cautiously, as a visitor from a vanished world rather than a native. The consensus is not that tigers are rare in Japan. The consensus is that the question of tigers in Japan does not need to be asked, because the matter was settled by geology before it could ever become a matter of biology. That settlement rests on fossil evidence pulled from cave deposits on Honshu and Hokkaido, teeth, jaw fragments, isolated long bones, dated to the terminal Pleistocene, roughly 12,000 years before present. The tigers were here. And then, according to the record, they simply were not, and the explanation offered has never needed refinement, because it was never really about the animal. It was about the water. The question is not whether a tiger could survive in the forests of Hokkaido. The prey base, the winter cold, the terrain, none of that is in serious dispute, because Amur tigers already survive all 3, a few hundred kilometers to the northwest, in conditions nearly identical to Shiratoko's. The question is why an animal with no ecological reason to be excluded from an entire archipelago has been treated, for 12 millennia, as though the exclusion were permanent, not enough to confirm, not enough to dismiss, but enough perhaps to ask what extinct in Japan was actually describing. A species that failed to belong here, or a border that closed by accident. To understand what closed, it helps to look at what used to be open. At the height of the last glacial maximum, global sea level sat somewhere between 120 and 130 meters below its current mark, enough to redraw the entire coastline of the Northwest Pacific. The Sea of Okhotsk contracted. The Soya Strait, which today separates Hokkaido from Sakhalin by a narrow but decisive channel of open water, was not a strait at all. It was dry ground, a land bridge geologists sometimes call the Mamiya connection, linking Hokkaido directly to Sakhalin, which was in turn welded to the Asian mainland along the Siberian coast. Further south, the Korea Strait thinned to a chain of exposed shelf and intermittent land, offering a second, harder route between the Korean peninsula and Honshu. This was not a narrow, improbable footbridge. It was a broad, walkable extension of the Asian continent, open for tens of thousands of years, long enough for entire faunal communities to establish themselves on what would only later become islands. Naumann's elephant crossed it, giant deer crossed it, and tigers, animals whose modern range already stretches from the mangrove deltas of the Sundarbans to the frozen taiga of Primorsky Krai, animals with among the largest historical distributions of any land carnivore on Earth, crossed it too, because there was nothing stopping them, and because tigers, more than almost any other big cat, are built to walk. Then the ice retreated. Meltwater poured back into the Pacific Basin over the course of several thousand years, and by roughly 10 to 12,000 years ago, the land connections were gone. The Soya Strait filled. The Korea Strait filled. Japan became islands in the sense the modern world recognizes, and every terrestrial species trapped on the wrong side of that transgression was left to either adapt to isolation or vanish from it. Some, like the Japanese sika deer, adapted, diverging slowly into island-specific forms. Others simply ran out of room, or ran out of prey, or ran out of time. It was not lost. That is the distinction the fossil record actually supports, and it is a distinction the phrase extinct in Japan has quietly erased for 12,000 years. Extinction implies failure, a species outcompeted, poisoned, hunted, starved into non-existence within a landscape it once called home. What happened to the Japanese tiger population, if the geological timeline is taken seriously, looks less like failure and more like abandonment by circumstance. The animal did not die out because Japan stopped being suitable habitat. Japan stopped being reachable. Those are not the same event, and they do not carry the same implications for what might still be possible now that a small, deliberate population has been placed back inside the fence. The trigger for that placement had nothing to do with restoring lost fauna for its own sake. It had to do with deer. Hokkaido's sika deer population has been described by prefectural wildlife managers in internal planning documents, using language usually reserved for public health emergencies rather than wildlife management. Unsustainable, structurally destructive, beyond the carrying capacity of the forest by a wide margin. Estimates place the island's sika population well into the hundreds of thousands, some assessments pushing toward 750,000 animals across the prefecture, a number that has climbed steadily since the near-total extirpation of the island's native wolf population in the early 20th century removed the last large predator capable of exerting top-down pressure on deer numbers. Without wolves, without any apex carnivore, the deer answer to almost nothing except winter starvation and vehicle collisions. And even those checks have proven insufficient. Undergrowth in affected forest sections has been reduced to bare browse lines. Sapling regeneration has collapsed in multiple monitored plots. Agricultural losses run into the billions of yen annually. Culling programs, human hunters, government-funded bounty systems, expanded hunting seasons have slowed the growth rate without reversing it. It was against this backdrop, and after years of quieter internal debate, that a small consortium of wildlife ecologists proposed something that would have been unthinkable a generation earlier. Reintroducing an apex predator, not the extinct native wolf, but its ecological equivalent in scale and impact, into a fenced and heavily monitored section of reserve land where its effect on deer density could be measured in isolation before any conversation about wider release. 6 Amur tigers were selected from a managed conservation breeding lineage, chosen for genetic diversity and for prior soft-release experience, and moved into the reserve's interior over a period of 8 weeks in early autumn. The containment design was built around conservative assumptions taken from mainland telemetry data. Adult male Amur tigers on the Russian mainland typically maintain home ranges in the range of several hundred to just over 1,000 square kilometers, and the reserve's planners built in a wide margin above that figure. confident the fencing and the terrain's natural choke points would hold. Within 4 months, that margin had been tested. Camera trap data showed the released animals patrolling boundary sections of the fence line with unusual persistence, probing weak points, following ridge lines that offered the shallowest grade for a body that size. Deer carcasses turned up in locations the original range models had marked as low probability. And then Tiger 7's collar went dark and came back 40 kilometers past a boundary that was supposed to be absolute. If you have made it this far into this story, you already understand that the interesting part is never the fence. It's what the fence assumes about the animal on the other side of it, and what happens when those assumptions turn out to be wrong faster than anyone expected. This channel exists for exactly that gap, the space between what an official record says a species can't do, and what a paw print in fresh snow suggests it just did. Subscribe if you want to keep following where this one goes. The reappearance of Tiger 7's signal did more than embarrass the containment engineers. It gave researchers a single, trackable case they could cross-reference against everything else the reserve's sensor network had picked up over the preceding weeks. Camera trap hits along a rough transit corridor between the reserve's northern boundary and the tiger's eventual resting coordinates. A partial scat sample recovered near a stream crossing, roughly halfway along that corridor, and a set of prints in soft mud at a site nearly 30 kilometers from the nearest fence section. All logged in the days the collar had gone quiet. Taken individually, none of it proves a single continuous journey. Taken together, it sketches one. An animal moving mostly at night, avoiding roads where cover allowed, crossing at least one river, and covering distances per night that exceed typical mainland dispersal averages for a resident adult male, though not by a margin outside what has been documented in exceptional cases among young dispersing tigers on the Russian mainland, where individuals occasionally travel well over 100 kilometers from a natal range in search of unclaimed territory. What made Tiger 7's movement notable wasn't that it exceeded biological capability. It was that it happened at all, from inside a system explicitly engineered to prevent it in an animal with no mainland experience of the terrain it was crossing. Not enough to confirm a pattern. Not enough to dismiss one, either. Because a single data point, however striking, is still a single data point. And the researchers monitoring the trial have been careful in their internal notes not to extrapolate a national tiger corridor out of one collar's 11-day gap. But 11 days was enough to reopen a question the reserve's own planning documents had treated as settled. Whether Hokkaido's terrain, its deer density, its winter cover, actually constrained an Amur tiger's movement the way the models assumed. Or whether those models had simply never been tested against an island that used to be part of the mainland the tigers came from. The paw print measured in March sits at the center of the physical evidence, and it sits there uncomfortably, because it does not match the reference data it should match. 16 centimeters, pad to claw, in snow firm enough to hold a clean impression, larger than the upper range recorded for adult male Amur tigers across multiple long-term mainland monitoring programs, where forepaw tracks in comparable substrate conditions typically top out several centimeters smaller. A single oversized print could be explained by substrate distortion, thaw-refreeze expansion at the edges, an animal placing weight unevenly on a slope. Field teams have seen tracks inflate under exactly those conditions before, and the trial's monitoring report flags the possibility explicitly rather than hiding from it. What complicates the dismissal is the scat DNA work that followed. Genetic material recovered from 3 separate sample sites across the reserve, sequenced and compared against the founding population's known genotypes, showed the expected parentage. No surprises there, no unaccounted for individual, but also showed elevated expression in a small cluster of growth regulatory markers when measured against baseline blood work taken from the same animals at the point of release 6 months earlier. Dr. Anna Sokolova, the trial's lead geneticist, has been cautious in characterizing what that means, and rightly so. 6 months is not nearly long enough to distinguish a genuine adaptive shift from ordinary developmental variation in still maturing subadult tigers. But the pattern is at least consistent with something biologists have documented elsewhere under a specific set of ecological conditions. When a large predator colonizes an environment with abundant, poorly predator-adapted prey and minimal competition from other carnivores, growth trajectories can shift measurably within a single generation, producing individuals that run larger than their mainland founder population, without any change to the underlying gene pool itself. Think of it the way a plant released from the shade of a forest canopy grows differently. Not a new species, not a mutation, simply an organism expressing more of its existing potential, because the constraints that used to limit it are gone. Hokkaido's tigers inherited a deer population with no evolved fear response to a large cat, no historical selective pressure to avoid ambush terrain, effectively behaving as prey animals released from 12,000 years of predator absence. If growth in the founder tigers is being shaped by abundance and ease of hunting rather than genetics, 16 centimeters stops looking like measurement error and starts looking like the leading edge of a trend. The 6-month dataset is simply too short to confirm. Not enough to confirm, not enough to dismiss. That sentence keeps surfacing in the monitoring reports for a reason. Every piece of evidence generated by this trial arrives with an asterisk attached, because every piece of evidence is, so far, a sample size of one collar, one print, one genetic snapshot in time. Predictably, that asterisk has become the entire argument for a vocal set of skeptics within Japan's conservation biology community, and their objection deserves to be stated plainly rather than waved away, because it is not unreasonable. If Hokkaido's tigers are adapting this quickly, this visibly, the skeptics ask, where is the corroborating evidence beyond one collar and one unusually large footprint? Where are the additional oversized tracks, the additional genetic outliers, the independent camera confirmations from outside the reserve's own sensor network? The rebuttal offered by the trial's supporters does not deny the thinness of the dataset. It reframes what the absence of additional evidence actually means, point by point. Monitoring coverage across the reserve's roughly 1,200 square kilometers of forested, mountainous terrain remains far from continuous. Sensor density sufficient to catch a deer or a fox reliably still leaves enormous gaps for an animal actively avoiding detection. And Amur tigers, unlike many trail camera regulars, are known for a level of behavioral wariness around novel objects that can suppress capture rates well below what raw camera counts would suggest. Classification bias compounds the gap. Ambiguous night footage, partial frames, motion blur at range are routinely logged as unidentified rather than tiger, discarding data that might otherwise support the pattern. Physical evidence itself is perishable in a way institutional skepticism tends to underweight. Scat degrades within days in warm, wet conditions. Snow tracks soften and lose diagnostic edges within hours of a temperature swing. A carcass can be fully scavenged and scattered by opportunistic feeders before a survey team ever reaches the site. And the scale problem cuts both ways. A territory measured in hundreds of square kilometers is exactly large enough to make an individual tiger's movements statistically difficult to catch consistently, and exactly large enough to make the absence of proof mean very little about the absence of the animal. None of that resolves the disagreement. The skeptics maintain, correctly, that a 6-month trial with a founder population of 6 animals cannot support claims of rapid adaptive evolution, and that measurement noise, individual variation, and simple bad luck with substrate conditions remain the more parsimonious explanations for everything observed so far. The trial's own researchers largely agree with that caution in their published framing, even as the raw numbers keep landing slightly outside where the models said they should. Both positions can be held honestly. Both are, at this stage, unfalsifiable by the data currently in hand. The camera on the ridgeline above Shiratoko is still running. It has been running every night since the trial began, cycling through motion-triggered frames that are overwhelmingly empty forest, snow, the occasional fox or deer crossing at a predictable hour. Once, at 3:14 in the morning, 6 months into a program that was never supposed to prove anything about whether Japan could still hold a tiger, it caught something moving too fast to resolve. An animal that, by every official account written before that trial began, should not have existed on these islands at all. In a landscape that spent 12,000 years listed as tiger impossible, for reasons that had nothing to do with the tiger. Whether Tiger 7's oversized track, its unexplained absence, and the small genetic anomalies turning up in reserve scat samples add up to an ecosystem quietly remembering what an apex predator is for, or simply to the ordinary noise of a small, imperfect pilot program still finding its footing, is not a question this dataset can close. What the fossil beds and the drowned land bridges make harder to ignore is the possibility that extinct was never quite the right word for what happened here. That a border drawn by rising water 12,000 years ago was mistaken by everyone who came after for a verdict on the animal itself. Not documented is not the same claim as not existing. Somewhere in that gap, a forest in northern Japan is still holding open a space it never entirely stopped shaping itself around, and the camera on the ridge keeps recording, waiting to see what, if anything, crosses the frame next.